Okay, so in this discussion, let's talk about the making of the ultrafiltrate. We know that the glomerular filtration that takes place um, happens because blood coming into the afferent arteriole is under fairly high pressure, whereas most capillaries cannot handle more than about 30 millimeters of pressure on the arterial side. The special glomerular capillaries can handle blood pressures that are about at the level of the mean arterial pressure, so around 80 millimeters mercury. The reason for its success is the fact that there are in fact fenestrations, windows as they are, in the capillaries that make up the glomerulus. These fenestrated capillaries can handle blood under high pressure. Not only that, but in order for successful filtration to occur, the higher pressure is necessary. The process, of course, is more than just simple filtration. For that reason, we call it ultrafiltrate, because what comes out on the other end here is not just simply a product of straight filtration. So what happens? If you were to take a cross section of the capillary, one would see that first of all, these capillaries are highly fenestrated. There's a lot of big spaces here, which then will allow for a lot of diffusion in the walls. These fenestrations right here would not be typically found in a ordinary capillary. But in this fenestrated capillary, we will, under high pressure, express a lot of volume of fluid and solutes out of there. The proteins, large proteins, which are negatively charged, as well as red blood cells, they are rebuffed by the electrochemical negative potential on the inside of this special capillary. This allows for large proteins and red blood cells to largely stay inside the luminal space, even under this high pressure. If perchance a protein should leak out, it would be engulfed by the pseudopodic extensions of one of these special structures that is referred to as a podocyte. These podocytes are macrophages on permanent loan, as it were, by the kidneys, and they guard the glomerulus on the outside surface, and if anything should come through these fenestrations, that is protein, there would be a chemotatic response and it would be engulfed. This then allows for a pure fluid structure with containing only small solutes like amino acids and glucose, for example, to make it into the Bowman's capsule or the glomerular capsule. Again, that's the reason why we call it the ultrafiltrate, because the ultrafiltrate is not just simply the product of straight filtration, like putting milk through a cheesecloth. This ends our discussion on the making of the ultrafiltrate.